Okay, so I want to take just a minute to look at a few different examples of raising numbers to some exponent. When you see an exponent like this, that 2 to the 2, this 2 right here is an exponent. Now, when you raise a number to an exponent, you multiply the base, which right here, 2 is the base. So if 2 is the base and you raise it to a power, you're going to multiply the base by itself to the number of times you see in the power. So to make that a little bit more clear, we have 2 raised to the power 2. So we're going to multiply 2 by itself 2 times. Now for problem number 2, we have 2 raised to the power of 4. So we're going to multiply 2 by itself 4 times. So we get 2 times 2 times 2 times 2. After you set yourself up to clearly see what operation you're actually doing, which is multiplying 2 by itself, in this case 4 times, you can start multiplying the numbers. So 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. Right here, 2 times 2 is 4. Now, if you have a negative number, and that negative number is the whole thing with the negative sign is inside parentheses, and the parentheses is raised to a power, everything inside the parentheses, like this negative 5, that whole thing is going to be multiplied by itself however many times the exponent tells you to multiply. So right here, we're going to multiply negative 5 by itself 2 times. And then negative times negative becomes positive. So here, and say, okay, these become positive. And we get 5 times 5 is 25. Problem number 4 is a little bit different. So here, I know it's weird when you're looking at this. You think, I don't understand exactly what that means when you have negative 5 to the power of 2. What that's saying is you are going to raise 5 to the power of 2, and after you do that, you're going to multiply it by negative 1. So the negative is not part of the exponent. So we can clearly write that as 5 to the power of 2 with the negative on the outside. What we get is negative 25, and that's equal to just negative 25. Now, problem number 5, whenever you have a fraction that's raised to an exponent, the exponent goes to the number in the numerator and the number in the denominator. So just a reminder, the numerator is the top part of the fraction, the denominator is the bottom. So here for problem number 5, this is the same as saying we're going to raise 2 to the power 3. We're going to divide that by 3 to the power 3. This is the same as 2 times 2 times 2 over 3 times 3 times 3. And then we get 8 over 27. Now, number 6. For problem number 6, this is just a rule you have to remember. Whenever you have a fraction that's raised to a negative power, you get rid of the negative in the power by flipping over the fraction. So here, 2/3 to the power of negative 1 is the same as 3 over 2 to the power of 1. So let's do a bonus problem. Let's say problem 7. Say you have 2/3 to the power of -2. That's the same as saying 3/2 to the power of 2. Because when you flip 2/3 and turn it into 3/2, the exponent goes from negative to positive. And our answer after we flip that over, get rid of the negative sign, is 3 squared over 2 squared, which is equal to 3 times itself, 2 times itself, and then we get 9/4.